Hi, I'm Daniel Bow, Mr. Bow, and this is lesson 2 for our 2-day online math thing that we're doing uh, for June. And for this lesson, which is the second lesson today, we're going to be covering Venn diagrams, subsets, and the universal set. Um, so our objectives for today are that you're going to know how to represent set relationships using Venn diagrams. You're going to identify subsets and proper subsets, which we'll talk about later, of course. Um, you're going to count the number of subsets in a set, and you're going to identify the universal set of a diagram that you see. So we got 4 things to do. Let's go ahead and get on the first one, which is Venn diagrams. So what is a Venn diagram? I'm sure you've seen them, and we'll talk about maybe some things ways that you've seen them before in some classes. But a Venn diagram is generally has circles, and we draw circles or ovals, and we label the set at the top. In math, it's in the inside, but sometimes in some other kinds, it'll be sitting there at the top of the circle. But it's always labeled as to what it is, and then the elements that are in it. And so you can see here I've got B, which is the vowels, and R, which is the numbers, the natural numbers 1 to 6, and then G, which is the primary colors. So this is another way to look at sets rather than the roster notation or the description notation that we used before. Each element in the set is written only once. So over here, we can see inside the X set circle, there's a 1, 2, and 3. And inside the Y set circle, there's a 3, 4, and 5. But we only write 3 one time. It's not 1 time in the X circle and 1 time in the Y circle. So for 2 times, it's only written 1 time. So each element in a set is only written once. And the overlap of the circles here, which is called the intersection, but we'll get to that tomorrow, helps us understand the relationship of the sets. And over here we can see there is no overlap. Nothing that is in B is also in R, and nothing that is in G is also in R, and nothing that is in G is also in B. But over here I can see easily that X and Y share this one element, and that's 3. So that's why Venn diagrams are good. And you've probably seen Venn diagrams before. You've seen them from science, I'm pretty sure. Generally in science, you're listing the set of characteristics of a couple of things, and you're trying to compare them. So, and again, no characteristic is repeated. And you may not have thought of these as sets, but they are. So this circle is the set of characteristics for weather, and this circle is the set of characteristics of climate. And we can see weather has some stuff, and climate has some stuff, and they share some things: temperature, precipitation, humidity, wind direction, and speed. And they share those in common, but we didn't write them 2 times. We only wrote them 1 time. Same over here. We're comparing plant cells and animal cells. Plant cells have certain characteristics, and animal cells have certain characteristics, and they share some, like ribosome. They both have a ribosome, and but we don't write the ribosome 2 times. Even though they both have the ribosome, we don't write the ribosome 2 times. We only write it 1 time, and we put it right there in the intersection. And we can have more than 2 sets of things. So over here, I'm still in science, because I think you guys will understand this a little bit more easily than with just numbers. I'm comparing the set of bird characteristics to the set of mammal characteristics to the set of reptile characteristics. And so we can see birds have this stuff, and mammals have this stuff, and reptiles have this stuff. And we can pretty easily see birds and reptiles both have these characteristics. So lower jaw, multiple bones, backbone, claws, nails, lungs. We can see mammals share this stuff with reptiles, that they're animals. They have backbone, they have claws or nails, and they have lungs. And we can see birds share this stuff with mammals. They're endothermic, 4-chambered heart, animal, backbone, claws. And additionally we can see all three sets share these characteristics, and that's really important. That's why we use Venn diagrams, so that we can see the relationships easily. So we're going to do some practice, and my practice is I've got two sets. X has the elements 1, 2, and 3, and Y has the elements 3, 4, and 5. So we're going to draw and label a Venn diagram to show the intersection of sets X and Y. So I'm going to switch to my whiteboard here really fast. Okay, and the first thing I'm going to do is I'm going to draw the set X. So I'm going to draw a circle, and my circle is going to be ugly. And at the top, I'm going to label the set X, and in here I'm going to write 1, 2, and 3. And it really doesn't matter where I write them. I could write them 1, 2, and 3. It doesn't really matter. And the next thing we're going to do is we're going to draw the set Y. It doesn't want to draw. Why doesn't it want to draw? Oh, okay. I'm in the wrong layer. Okay, so I'm going to draw my set. Oh, and label it Y, and I'm going to put the elements in there 3, 4, and 5. And then we're going to, now that we know how to do that, we're going to try and draw both of them. So I'm going to find the things that are, change my layer again. Find the parts that are similar and put them in the intersection here. So I have 1, 2, and 3 over here, and I have 3, 4, and 5 over here. 3 is in both. 1 and 2 are in X, and 4 and 5 are in Y. So Y has 3, 4, 5, and X has 1, 2, 3. And that's how we draw a Venn diagram, just in case you'd never done it before. I think you guys have probably done it before, but we have to, make sure. So, what about Python? Well, Python probably has a library somewhere where you can automatically generate Venn diagrams, but we're not going to do that today, so we're not going to do anything with Python for this topic. And so we're just going to move on right now. Our second topic is, what is a subset? So we say that one set is a subset of another set when every element is also in that other one. So A is a subset of B because every element that is in A is also in B. So it's contained in B. A is contained in B, and we're going to use this this notation over here, which we'll read is a subset of, and then we can hash through it and say is not a subset of. And I like to compare these to less than or equal to and not less than or equal to, which you should probably already know. So less than or equal to, it's the same or smaller, and so we can see X is the same or smaller than Y, and A is the same or smaller. I'm using some non-mathy words here, and D is the same or smaller than C. So we call that is a subset of. You can't say is less than or equal to. Okay. So A is a subset of B, but B, all the elements of B are not in A. There's a 5 and there's a 3 that is not in A. Therefore, B is not a subset of A. Y is not a subset of X. Let's look over here. I have two sets. D has 1, 4, 5, 7, and 8. C also has 1, 4, 5, 7, and 8. So in the Venn diagram here, we can see that D is a subset of C. But it's just the way we drew it. We could actually swap these letters and put D on the outside and C on the inside, and it would mean the same thing. Therefore, C is also a subset of D. And when D is a subset of C, and C is a subset of D, when D is a subset of C, and C is a subset of D, then C equals D. And we can see that C equals D. They have the same elements. That brings us to the idea of a proper subset. So a lot of students, when they hear subset, they think it has to be smaller, has to have fewer elements, it has to be inside. But it doesn't really. We saw that. So the way that we talk about that one, that has to be smaller, has to be a smaller set, has to have fewer elements, is a proper subset. So a proper subset means that everything that is in X is also in Y, but there are some things in Y that are not in X. Or everything that is in A is also in B, but there are some things in B that are not in A. So A is a proper subset of B. We use this term here. You can see it doesn't have that little line on the bottom that's kind of like the equals and less than are equals. So this is more like less than, okay? Or we can say is not a proper subset, which is more like that is not less than. So B is not a proper subset of A. And if we go back over and look at our old example, D is not a proper subset of C, because there's nothing in C that is not in D. And I have over here not always true. So I want to talk to you guys about the notation. Set notation, there's a lot of ways to write it. And some mathematicians, depends on where you're from, some mathematicians use this symbol to mean subset, and then they don't really have one for proper subset. And they're a bunch. You'll see it all over the place in math. There's a bunch of different ways to write almost everything, because it kind of came up from a lot of different people at about the same time. And they set up a way to write something, and some people followed one mathematician, and some other people read the books of the other mathematician, and so we've got some different schools, just like we've got different religions, basically, and different languages and such like that. So we have different alphabets to represent the same sounds, and we also have different notation to represent the same concept. So this sometimes, in some cases, this can mean subset depending on who you're talking to. But for me, in today, it's going to mean proper subset, and subset will be this this one with the line underneath, meaning equal to, right? Okay. So this is our practice. What's the relationship here? We want to know what the relationship is here. So I want you to go ahead and think about it for a minute, and write down a note. Is it a subset? Is it a proper subset? Okay, so we're going to come back. The first thing we can look at is the number of elements. So this one has 3 and this one has 5. So there is something in B that is not in A for sure. So B cannot be a subset of A. So A may be a subset of B, and we have to check. And there's 2 ways we can do that. One is we can just check for the elements. Is 1 in B? Yes, it is. Is 2 in B? Yes, it is. Is 4 in B? Yes, it is. So then A is a subset of B. Or we can draw a Venn diagram, and we can see that visually A is a subset of B, because everything that is in A is also in B. And because there are some things out here, A is also a proper subset of B. So we can say either of those. A is a subset of B, or A is a proper subset of B. Either one of those answers is right. So here's our second practice. X is the letters A, R, and E, or the letters in the word R, or ear, I guess, too. Or era. Lots of words. And Y is the letters R, E, A, D in the letters in the word read or deer. So we want to know what the relationship is between these. So I'm going to give you a second, look at it, write down what you think. There's no right or wrong answer. Well, that's not exactly true. There is this one doesn't count, so you can get it wrong and it won't count. Okay, so we can count the number of elements. X has 3 and Y has 4. Y has 4 elements. So we know that Y cannot be a subset of X, and so we can check if every element in X is in Y. A is in Y, R is in Y, E is in Y. So we know X is a subset of Y. Or we can draw it out graphically, and we can see that everything that is in X is also in Y, and that there is something in Y that is not in X. So therefore, X is a subset of Y, and X is a proper subset of Y too. So either one of those answers is correct. So this is the one that counts. This one's going to count for a point. I want you to check the relationship between these two, P and Q. Okay, we can see again, P has 3 elements, Q has 5 elements. So we know that Q is not a subset of P, and we know that P could be a subset of Q. So let's check 1. 1 is not in there. 1 is not anywhere. So so we know that when we draw out a Venn diagram, it looks like this. And P is not a subset of Q, and Q is not a subset of P. Not a proper subset either, of course. Okay, so what about Python? Well, let me switch to my coding environment here. So I'm going to get into Python. Okay, so I'm going to set up 2 sets. Set A, and it's going to be 1, 2, 3, 4, 5. And I'm going to create set B here, and that's going to be 1, 2, 3, 4, 5, 6. And I'm going to create set C, and let's make that 2, 3, 4, 5, 6. Okay. Let's just make it 2, 3, 4, 5, 6. I'm going to make it 6. Okay. All right. So now I'm going to ask if it's a subset. In order to do that, we have to look at an attribute. Have to look at an attribute of the variable, the set variable. So how we do that in Python is you do something after a dot. So there are certain now we're in the set A variable, and we're looking at some attributes, some characteristics of the set A variable. And one of those characteristics is it a subset? And so we want to know, is A a subset of set B? Is set A a subset of set B? And we can ask it that way. And it is. But we can do the same thing to ask if set C. Is it a subset? Trouble typing of set B. And yes, it is, because we can see 2, 3, 4, 5, 6. So, but if we ask if set A is subset of set C, we're going to get false, because the 1 is not in C and 6 is not in set A. And if I ask about set B, is set B a subset of set A? It's going to tell me false, because 6 is in B, but 6 is not in A. So that's how we do that in Python. All right, so we got 2 more things to talk about. We're going to ask about counting the possible number of subsets. I have an example here. Set C has the elements 1, 2, and 3, and we're going to list those out. And we're going to list them out starting out with 1 element. So let's see, we can make a set with 1, or we can make a set with 2, or we can make a set with the element of as 3, and those are all subsets of this set because 1 is in C, and 2 is in C, and 3 is in C. And then I'm going to look at the number, the sets that have 2 of these elements. So if I take 1 and 2 and I make a new set with 1 and 2 as elements, then that's a subset of C because those are also in C. And 1 and 3, that's also a subset, and 2 and 3, that's also a subset. And then I'm going to take the take all 3 elements. So if there's 1, 2, and 3, if I make another set that has 1, 2, and 3, then that set is a subset of C. It's not a proper subset, but it is a subset. And I forgot one. I need to find the set with 0 elements. That is the empty set. Is the empty set a subset? It is. So after we list these all out, we get this thing over here. So we take them 1 at a time, 2 at a time, 3 at a time, and 0 at a time. And I can see over here I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 subsets. And this is going to be related to something we'll study later this year, which is combinations. But I'm going to introduce you to it a little bit here. So if I have 3 things and I want to find out how many ways I can take 0 of them, that is 1. There's 1 way. And I want to find out the number of ways up in here that I can have 3 things, 3 elements, 3 things in a bag, and pull out 1. How many different ways can we do that? And there are 3 of those, right? So I can have 1 or 2 or 3. And the combination of taking two elements from 3 elements, there are 3 ways to do that. 1, 2, 3, right? 2 at a time, 2 at a time, 2 at a time. So 1, 2, 1, 3, 2, 3. And then I want to take 3 elements out of a set of 3, and there's only 1 way to do that, which is 1, 2, and 3. And so when we add that together, 1, 3, 3, 1, then we end up with 8. And 8 is a special number in computers, and computer people recognize 8 as 2 to the 3rd, because we all know all of our binary numbers, because they're so important. So I read it immediately. I recognize that this 8 number is 2 to the 3rd, and this 3 is repeated a lot in here. So I have kind of a hunch. I have kind of a theory that that may be important. So let's look at another example. Another example, my set is R, and it has the elements X, Y, and Z. So we need to count the number of subsets. How many are there? Let's see. So I need to start with 1. All of the sets that have 1 element. So there's X, and then there's Y, and then there's Z, and then I need to count all of the sets that have 2 elements from here. So that's X and Y, X and Z, Y and Z. So that's 3 again. And I need to count all of the sets that have 3 elements. 1, 2, X, Y, and Z. There's just 1 of those. And I need to count the empty set too that has 0 elements. Excuse me, I have an itchy nose. That has 0 elements, and there's 1 of those. And we could count the number of elements that have the number of sets that have 4 elements, but there are 0 of those. So for 5 there's 0, and for 6 there's 0. So we don't need to count them. And when we list those out, we get this. And wow, that looks really familiar. That looks like we did just almost exactly the same thing as we did back here. We did exactly the same thing, but it's just 1 becomes X, and 2 becomes Y, and Z becomes 3. There's no difference. We ended up with the same number. We ended up with 8. And again, it's because we're taking the number of combinations. How many ways to take 0 things from 3? There's 1. How many ways to take 1 thing from 3? There are 3 ways. How many ways to take 2 things from 3? There are 3 ways. And how many ways to take 3 things from 3? There's 1 way. And altogether, again, that's 8, or 2 to the 3rd. And it turns out that the general rule for the number of subsets is 2 to the n, where n is the element. number of elements in the set. So I'm going to ask you to count the number of subsets. So first thing we're going to do is you're going to list all the subsets of the set C, 1, 2, 3, and 4. So remember, 0 elements, 1 element, 2 elements, 3 elements, and 4 elements. I know that my fingers don't match up with the numbers that I'm saying. So list those out right now. Okay, so this is the full list that you should have gotten. If your set names are not the same, it doesn't really matter. And of course, if your numbers are not in the same order, it doesn't matter because order doesn't matter for sets. So how many are there? And I want you to answer that question right now. Okay, so how many are there? So we have how many elements? We have 4 elements, and we back here we said 2 to the n, so 2 to the 4th. 2 to the 4th is 2 times 2 is 4 times 2 is 8 times 2 is 16. So 2 to the 4th is 16. So our answer is 16. So what about Python? How do we do this in Python? Let me switch to my coding environment here. Sorry, it takes me a second. And I'm going to go ahead and exit out and clear this. Okay, so so I have a set, and I'm going to define that as I don't want to type a lot of I don't want to type a lot of quotation marks, so I'm not putting any words or strings in there. So, but we could, but I wanted this to be fast, so you can see there's a lot of elements in here, and this could keep going on. There's a lot of elements in here, and it's going to be hard for us to just list them all out. And this is where a computer comes in handy, calculator in this case. But we want to find out how many elements there are. And so in Python, the way we find out how many elements there are, we use the length command. And so we can find the length and find that there are 8 elements. And then what was our rule? Our rule was 2 to that power, 2 to the power of 8. So I could just say 2 to the power of 8, but we don't want to have multiple steps. We want to write a Python program. So we want to find out the number of elements and find the answer in the same step. We don't want to do 2 steps with that. So I originally tried this, but that doesn't work in Python. I didn't know how to do exponents in Python, but it turns out that they are 2 asterisks, and 1 asterisk means multiplication, and 2 asterisks kind of we can think of that as multiplication raised to the next level, which is exponents, right? We have multiplication is repeated addition, and exponent is repeated multiplication. So that kind of makes sense. And then I'm going to put, and there we go. So the number of possible subsets for set A with 8 elements is 256. If we have another set B, which has more elements, then I can just run back that command again, and we have 32,000 odd possible sets for that. So let's go on to our last thing, and the last thing is going to be pretty easy. It's called the universal set. So here I have 2 sets. I have set A, which has 1, 2, 5, and 6 in it, and I have set B, which has 3 and 9 in it, and they don't have anything in common. They're not subsets of each other. There's no intersection, which we'll talk about tomorrow. So what can we say about them? We can't say a lot about them unless we imagine that there's some larger set that they are both part of. And Here, I've imagined that there's some part of some larger set, which is the natural numbers from 1 to 9. So from 1 to 9, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And B has some of them, and A has some of them. And some of them aren't used. So you can see this set always has the letter U and is called universal. So that's the largest set that we can have, whatever we're talking about. So the universal set is the largest set that we can have of whatever our constraints are. So A is a subset of U, and B is a subset of U. And everything will always be a subset of U because U is the biggest set that there can be, the largest set that there can be. So in this case, also A is a proper subset of U, but it doesn't always have to be true. If A had all of the numbers in it, then A would not be a proper subset of U. So what about Python? There's not really a lot that we can do in Python. We can find the union, which is all of the elements that are in both sets combined, a new set, like you add the two sets and you create a new set. We can do that, but that's actually called union. So there's no really corollary for the universal set in Python. And that finishes our lesson for today. I need you guys to go back into the Discord classroom and contact me about your coding challenge for this. So I appreciate your time today, and I will see you in a couple of seconds.